my dear taste buddies. How are you? I hope you are doing fine right now. For today's video, I'll be discussing to you on how to perform estimation and basic calculation together with the abbreviations for measurement. Are you guys ready? Well, me too. I am so much ready. But before we proceed to our discussion, let's have a recap first. Last time, we talked about the nature of food processing, the different processing methods, and its positive and negative impacts. As we continue with our learning discussion, I want you to evaluate some of the practical situations in food preparation. How will you make sure that you get the right taste of your product at the end of the food process? How will you ensure the quality of your product in maintaining the right texture, appearance, temperature, and taste? How do you benchmark your food process instructions to maintain good quality of your overall product? If you want to know the answer, stay tuned and together we will learn. But before we continue, I would like you to know our learning objectives. And these are the following. You should be able to, first, identify the weight and measure equivalent. Second, use the correct abbreviations for measurements. Third, convert measurements and temperature. And lastly, you should be able to describe the difference between accuracy and precision, and identify sources of error in measurement. Humans use their body parts and their surroundings to weigh and measure in early civilization. For instance, a hand and a finger can be measured length. Seeds, grains, and stones were used for weight. Time was measured by periods of sun and the moon. However, weights and measure were not always the same because seeds, stones, and people's hands are different in sizes. Weights and measures were standardized as the civilization developed. In the field of cooking, measuring spoons have been around for many years to measure ingredients required in food preparation. Fanny Farmer, a director of Boston Cooking School, invented the first standardized measuring spoon in the year 1896. The need for the standard measurement system is necessary to make sure that each weight and measure standard is accurate. Success in food preparation depends on using the correct amount of ingredients as stated on the recipe. The only way to get the correct amount is by measuring or weighing each ingredient. Measurement is the process or the result of determining the ratio of a physical quantity such as a weight, length, time, temperature, etc. to a unit of measurement such as the meter, second, or degree Celsius. The scientific study of measurement is called metrology. On August 6, 1906, the system of weights and measures were reformed and legalized in terms of metric system when the Philippine Commission Act No. 1519 was enacted. But because of irregularities and fraud, the international metric system was adopted for a more uniform system of measurement that effect on January 1, 1907. All measuring systems have basic units for length, mass, capacity, and temperature. The basic unit for the metric system are shown in this table. Note that the abbreviation or symbol of the unit is not followed by a period and that all the abbreviations are lowercase letters, except for liter, which is usually a capital L. In the metric system, the basic units are turned into larger or smaller measurements by using a prefix that carries a specific meaning as shown in this table. The most commonly used prefixes are kilo, centi, and milli. Now, let's move on to the units of length. The basic unit of length or distance in the metric system is the meter. The most frequently used units of length used in the food industry are the centimeters and millimeter. The units of length in the metric system are shown in this table. Now, let's move on to the units of mass. Mass is the amount of material an object has. The most frequently used units of mass or weight used in the food industry are the gram and kilogram. The units of mass in the metric system are shown in this table. Note that certain metric terminology is not regularly used for production and service. The average cook or chef will not remember how many grams are there in hecto, deca or deci, or centigram. It is much more practical to write and read 100 grams in a recipe than 1 hectogram. Now let's move on to the units of capacity. Volume is the amount of space something occupies. The basic unit of volume or capacity is the liter. The most commonly used units in cooking are the liter and milliliter. The units of volume in the metric system are shown in this table. Occasionally, you will encounter a unit of volume called cubic measurement. A cubic measurement sometimes used to express the volume of solids or the capacity of containers. And the units will be expressed as cc or cubic centimeters. Cubic centimeters are the same as milliliters. That is, 1 cc is equal to 1 milliliters. And now, let's talk about recording of weights and measurements of raw materials and ingredients. Accurate and correct measuring is essential in food preparation. We measure to approximate the amount required in a formula using the right measuring device and applying the right measuring techniques. It is important to know a few basic equivalents. In food processing industry, weighing is the most often used. It is the quickest and the most accurate way to measure raw materials. Different people may use identical recipe for molded desserts. All of their molded desserts could turn out differently because of different measuring and mixing techniques. The following section presents some important measuring equivalents, tables, and conversions. And here are the following tables of weight and measures. This table shows the measurements and equivalents of a liquid. And this table shows the equivalent measurements using cups and spoons. And this table shows measurement in terms of oven temperature. And now, let's move on to the abbreviations for measurements. Abbreviation is just simply shortened form of a word to save space in writing formulas. It's great to try new recipes when cooking for yourself or for others. But what happens when you run into an unfamiliar abbreviation or term when measuring your ingredients? You may know the basic of cooking measurement, but there can be a big difference between a TSP or a TBSP when preparing a meal, so it's best to be sure. Here are some measurement abbreviations that are perfect for reading recipes, packaging labels, and nutritional informations. For the volume measurements, a set of measuring cups and measuring spoons can only get you so far. If you don't know what the recipe is asking for, no measuring spoon will save your dish from disaster. You may see these abbreviations in cookbooks, packaging labels, nutritional information, and many more. And for weight measurement, the United States typically uses pounds to measure the weight of ingredients. However, countries that use the metric system employ grams to describe how much of an ingredient one should add. Some common weight abbreviations include other measurement units that describe size and amount of an ingredients we have. Now, let's move on to the temperature measurement and conversion. Temperature refers to the degree of hotness or coldness of a body. The metric unit of temperature is degree Celsius. In the Celsius scale, 0 degrees Celsius is the freezing point of water, and 100 degrees Celsius is the boiling point of water. The instrument used for measuring temperature is thermometer. Another unit of temperature is degree Fahrenheit. The Fahrenheit scale is the scale that is used when they report the weather on the news each night. It is probably the temperature scale that you are most familiar with. The thermometer that you have in your house for uses such as swimming pools, cooking, bathtubs, or reading body temperature are all likely to be in Fahrenheit. To convert degree Fahrenheit to degree Celsius, all you need to do is first subtract 32 from degree Fahrenheit, then multiply by 0.56. For example, now let's move on to the Celsius scale. Celsius scale is commonly used for scientific work. The thermometers that we use in our laboratory are marked with a Celsius scale. The Celsius scale is also called the centigrade scale because it was designed in such a way that there are 100 units of degrees between a freezing point and a boiling point of water. One of the limitations of the Celsius scale is that negative temperatures are very common. This is why the Kelvin scale was necessary. To convert degree Celsius to degree Fahrenheit, all you need to do is simply multiply degree Celsius by 1.8 and add 32. For example, now let's move on to the summarizing and tabulating all raw data gathered. Presentation of data is of utter importance nowadays. After all, everything that's pleasing to our eyes never fails to grab our attention. Presentation of data refers to an exhibition of putting up data in an attractive and useful manner such that it can be easily interpreted. Any set of information or data collected for study should be organized and analyzed systematically for easier and faster interpretation. To do this, collected data may be presented in any of the following forms. First, we have the textual forms. The textual forms are used when data to be presented are few or the data that being collected is minimal. Second is the tabular and graphical forms. These forms are used when more detailed information is to be presented. Graphical presentation of data portrays numerical figures or relationships among variables in pictorial form. Example of tabular and graphical forms we have line graph, bar graph, pictograph, and pie graph. Using tables and graphs has the following advantages. First, data are presented in a more practical and convenient way. Instead of writing text on the information gathered, items can be enumerated in tabular form or shown in graphical form. Second, data can be compared more easily. Recording tables and graphs can be done more easily because the needed information can be seen at a glance. The third one we have, data can be analyzed comparatively. Tables and graphs enable an analysis of data because all needed information is clearly known. Now, let's proceed to our next topic, the recording skills. Measurement is essential for us to understand the external world. And through million years of life, we have developed a sense of measurement. Measurements require tools that provides people with a quantity. The problem here is that the result of every measurement by any measuring instrument contains some uncertainty. This uncertainty is referred to as error. Accuracy and precision are two important factors to consider while taking measurements. These terms reflects how close a measurement is to a known or accepted value. In recording skills, we need this following. First, accuracy. Accuracy refers to the closeness of a measured value to a standard or known value. For example, if in laboratory, you obtain a weight measurement of 3.2 kilograms for a given substance, but the actual or known weight is 10 kilograms, then your measurement is not accurate. In this case, your measurement is not close to the known value. Accuracy is expressed as either an absolute or a relative error. Absolute error is the actual difference between measuring value and the accepted value, while relative error is expressed as the percentage and often called percentage error. The accuracy of the system is classified into three types. First, point accuracy. The accuracy of the instrument only at a particular point on its scale is known as point accuracy. It is important to note that this accuracy does not give any information about the general accuracy of the instrument. The second type, we have accuracy as percentage of scale range. The uniform scale range determines the accuracy of a measurement. The third type, we have accuracy as percentage of true value. Such type of accuracy of the instrument is determined by identifying the measured value regarding their true value. The accuracy of the instrument is neglected up to 0.5% from the true value. Now, let's move on to the next skill that we need in recording. We have precision. Precision refers to the closeness of two or more measurements to each other. Using the example, if you weigh a given substance 5 times and get 3.2 kilograms each time, then your measurement is very precise. Precision is independent of accuracy. You can be very precise but inaccurate. You can also be accurate but imprecise. Precision is sometimes separated into repeatability and reproducibility. Repeatability, the variation arising when the conditions are kept identical and repeated measurements are taken during a short time period. While reproducibility, the variation arising using the same measurement process among different instruments and operators and over longer time periods. Now, let's move on to our last topic, the error. All measurements are subject to error, which contributes to the uncertainty of the result. Errors can be classified as human error or a technical error. Perhaps you are transferring a small volume from one tube to another and you don't quite get the full amount into the second tube because you spilled it. This is example of human error. Technical error can be broken down into two categories: the random error and the systematic error. Random error, as the name implies, occurs periodically with no recognizable pattern. Systematic error occurs when there is a problem with the instrument. For example, a scale could be improperly calibrated and read 0.5 grams with nothing on it. All measurements would therefore be overestimated by 0.5 grams unless you account for this in your measurement. your measurement will contain some error. Again, to sum up accuracy and precision, accuracy is a degree of closeness between measurement and the measurement's true value, while precision is the degree to which repeated measurements under the same conditions are unchanged. At this point, we are about to end our discussion, and for that, I will give an assessment to evaluate your knowledge about our lesson for today. For your assessment, look for a particular product, then observe its packaging and nutrition information. Then determine the units of measurement used for the following: grains, solids, liquids, and herbs and spices. Compile the data in a word processor using a tabular or a graphical form. Wow! What a fruitful learning! I hope you learned a lot from our discussion today. Once again, I'm Sir Johan Quadra, your TLE teacher. See you on our next lesson. Happy learning!